Next one, you were told that the price is $680. You sell 70 cameras. So right off the bat, you know that your two numbers you're going to work with in the parentheses, 680 and 70. Everybody okay with that? 100. So I know that I'll have 680. And what was the other one? 7. Thank you. And then if you go back and reread it, it tells you that for every $20 decrease in price, you sell 5 more cameras. So what am I going to do with the 680?
Minus 20x.
Minus 20x, and what do I do to the 70?
Plus 5x.
That's it. So when you set that up, you have minus 20x plus 5x, and now I'm going to show you guys again to find that midpoint, and then I'll also show you how you can do that in the calculator. Here, I'm going to find my two zeros. Everybody agrees that this is another parabola that's down like a frown. It's going to cross the x-axis at 2 spots. We're going to figure out what our zeros are. Okay? Is everybody okay on that?
Yeah.
All right. Now, the first zero is going to be negative. I'm going to take, well, let me do it this way. I set this equal to 0, and I get 680 equals 20x. Is everybody okay with that set? All right. Divide it by 20, you get what? 34? Okay. So I have one zero here at 34. The other one, I have 70 equals negative 5x. So when I divide that out, I get a negative 14. Thank you. So halfway between negative 14 and 34 is how much? 20. Well, you add them together, then you got to cut it. We're finding the midpoint of that. So it's at 10, yeah. So the halfway point here is going to be at 10. So that means that I think the question, you reread it here. The question asked us, how much should the manager charge to maximize the monthly revenue? What is the monthly revenue? So what should I charge? Well, I need to use that x value of 10. So that means I multiply 10 into here, and I get 680 minus 200. So in order to maximize my profits, how much did I sell a camera for?
480.
480. And what was that maximum value then? If you, no, go ahead.
57,600.
That's a lot of cameras. Okay. See, what we're doing here is we're just finding this value. When you're working with this style where you have a price and sales units, it's a very simplistic, get a 0, find the maximum. In the calculators, if you did it that way, what was it, 680, thank you. And when I graph this one, again, I don't think I'm going to be able to see it. I want to go through the window. So where was it? Negative 14 and 34. So we'll go at okay, so it's still going to be way up there. Now, we knew that, what was it? It's like 50,000, 57,000. So I got to change my window to like 60,000, yeah. So sometimes the benefit of finding out that table value first, where that halfway point occurs, especially with clean numbers, it's going to help you get that other value easier. Yes, ma'am?
Wait, so what is finding the first number have to do with finding the next number?
What's this x coordinate here?
Yeah, but I don't get how you use that to find the next number.
The x, all right, when you're working with a parabola, your vertex is either a maximum or a minimum. When the parabola is down like a frown, that's the peak. That's the maximum value. The x value generates the y. When x is this, the y value is their highest point. Think of it in terms of height. When the x is here, the highest spot is 57,000 something. When x is to the right of it, it's not as tall. It gets taller and then drops down. that value of x makes the function the biggest. Okay? When x is equal to, what was it? 10. When x is equal to 10, the function is at its highest spot. That's the maximum value when x is 10. That's what you're finding. So in our mind, we're saying that when I go back and relate it to the revenue, when x is equal to 10, it multiplied into that formula of 680 minus 20x times the other stuff. That generated that 500 or
I
57.
got that, but as soon as I can put the radios in, I switch out to
No.
radios and then
No. That's why they have the calculator.
there's no way to do that.
You can multiply everything out if you want, but I'm not. When x is equal to 10, when x is equal to 10, the value of the function, is what you're doing is you're taking 480 times 507, and that's the biggest number you're going to get. Does that make more sense? That's what it's just like plug and chug. When you're looking at the graph, you hit the second, after you change your window, you have to change the window around to make it so. Your x's and your y axis, x maximum, your y maximum, things like that. You're trying to change the window to see everything on the screen. Okay? Now, when we get into the other part, the Big Bertha one, Big Bertha one should have been relatively straightforward.
Yes.
Yeah. When you look at the Big Bertha problem, think about what you're looking at.
Oh, that one.
You're talking about a cannon.
I got that one.
Cannon goes boom, kablooey. Okay? 101. So the cannon starts at something and it ends somewhere, and bad things happen. What you're looking at doing is, all you have to do with this style is, yes, you have to use your calculator to model this one out. Let's see, do I have, I don't have mine. When we do that one, you have all right. So go back to your y equals table. I'm going to put in my calculator negative 0.0196 x squared plus 1.37 x. All right. Now x is that horizontal distance for where it started. Now, does everybody agree that when I graph this, I don't know what else to show up on my, I don't see it on my window right now. So for those of you guys trying to figure out how to work with windows, what we're looking at is, think about a cannon has to start somewhere, right?
Yeah.
It starts at the cannon. It doesn't start below. I mean, all right, could you shoot a missile from underground? Yeah. But we start measuring height at 0, right? So it's going to go whee, kaboom. So what I'm trying to do here is I'm going to adjust my window to try to visualize it. So do I need to have anything in my window really that much negative, more than negative 10?
No.
Not really. My x maximum, I don't know how much it's talking about in terms of miles, so let's just say 200 miles. My y minimum, I could probably leave that at negative 10 again. Now cannons, do cannons shoot 60,000 miles in the air?
Yes.
No.
Oh.
I hope not. That's a big cannon there. Might set it up to 100. I don't even think a cannon can shoot 100 miles in the air. That's still pretty far. Hey, look at that.
Miles.
I'm still way out there, but you guys get the general idea of what it looks like. Everybody okay with that? Now, what you're looking for now is, we know that's going to start at 0 and it's going to cross the x-axis again here at 0, right?
Yeah.
So if I go to my table, I was just start scrolling down.
On the biggest line.
I'm not even worried about that. I'm looking. Well, what I'm doing right now is I'm going to go. We'll go back and recalculate the maximum on the calculator. But what I'm doing here is just I'm scrolling to see if I can figure out where what goes up must come down. So right now it's still on its way up. It's coming down now.
Should go big line 0.
Basically, I'm looking to see where it goes to.
Oh, I didn't know.
So we're still coming down. It's 70 miles. Oh, so somewhere about almost 70 miles it's shooting because this X value is in miles. Does that make what we're looking at here?
Yeah.
Between 69 and 70 miles, it jumps.
That's a lot of money.
Between 69 and 70 miles, it's jumping from positive to negative.
Yeah.
Does that make sense?
Yes.
So I'm going to say it shoots about 70 miles. I'm not going out there with a tape measure. I'm saying that if we shoot Big Bertha from our high school, we could probably hit Lake Michigan. That's how far that shoots.
How is that possible?
That would be awesome.
Okay? So overall distance is about 70. Yes, sir.
How did you find 70 again?
I just went through here. I'm looking at what I'm thinking about is remember a cannon goes up and comes down. This is your horizontal distance. Where does it cross again? The x-axis. It crosses the x-axis at about 70 miles. Notice how it jumps from being 1 mile above ground, being below ground. So between 69 and 70 miles, it crossed 0.
Yeah, but I mean, how did you get 70?
How did I get that? I was just going through the table, just scrolling through, looking where it went from positive to negative. Where does it make that shift? Yes, and double it. And your middle point here is going to be at about 35 again.
Yeah, I found 35.
Yeah, and that's the same basic principle. What she was doing there, guys, what Izzy did was she found the maximum, the midpoint really. The maximum value here occurs at about 35 for x. If you solve through it or if you hit the calculator. Now, if you're starting a cannon at 0 and your maximum value is at about 35, when you go to the other side, wouldn't it have to be at about 70?
Yeah.
Because of the way that the parabola works. Okay? So that's how that one sets up.
How do you find the maximum height?
How do you find the maximum? What was the y value at 35 for x? Remember, what you're finding here is if this is 70 for x, y is 0. Here's 0, 0. 35 is your x coordinate. When you go back in your calculator, if you just want to go right to your table set, let's say it was 35. Yeah. So it's at basically 24 miles high, 23.94 miles. So you can say approximately the height would be 24 miles. Does that make sense?
Yeah.
Your x value is generating the y. Your y value is how high up is it going, the vertical distance versus horizontal distance being shot. Okay? Eh?
I mean, I get this one, but where problems are now.
It's one of these things. I think that was all of those, right?
Yeah.
Okay. 75.
Wait, are we just doing this all day, or are we actually learning?
We are
I'm
learning.
working through these to help you guys out.
That definitely helps out.
This grouping in here in the 5-5 stuff, finding the area thing, solving for x here, this should have been relatively easy. Remember, you're looking for the x value to be positive when you do this. Yeah. Sure. Area of a trapezoid. Do you remember how to solve the area of a trapezoid? No. Isn't it? Aren't all these area formulas in your agenda?
No.
Oh, they actually are.
Yes.
You have what?
I have like an algebra 2 with like all the formulas in it. I think.
So the area of a trapezoid is 1/2 the height times the sum of the bases. So 70 has to equal 1/2 of x plus 4 times 4x. Okay? So you have 1/2 the sum of the bases. I would just multiply by 2. I get 140 is 4x squared plus 16x. Subtract the 140. And go that way. Okay? Does that make sense?
Yeah, I said it up right.
Oh, okay. Oh, let's see here. Can I divide 140 by 4?
Yeah, it's 35.
Okay. So we have x squared plus 4x minus 35. What I did here, since I'm solving for my zeros, I divided everything, I divided it out to GCF. What times what's negative 35 to add together to get positive 4? It's 7 and 5, so it's really not going to work, is it? So I'm going to use quadratic formula. Or do you want to complete the square? Complete the square would probably be a little bit easier because you have an even value. So let's do that. We have x squared plus 4x blank equals 35 blank. Oops. Half of 4, well that's easy. 2, square it. Oh, that's 4. So our terms here are going to be x plus 2 quantity squared is 39. When I add this out, or excuse me, when I solve that out, I get x is going to equal negative 2 plus or minus the square root of 39. Now, when we're dealing with areas, we're talking about side lengths. It can't be negative. So in this case, which one am I going to throw out? The negative 2 plus root 39 or the negative 2 minus root 39? Yeah, I'm going to throw out the negative 2 minus root 39. So my only answer is going to be negative 2 plus root 39. All right. Because that'll give me a because the square root of 39 is more than 6. So I know that that value is going to be a positive number. Okay? It'll be 4-ish. All right. Does that help on that? Yeah. Okay. Let's go into the other parts on that one. Jackie Joyner Kersey and Stopping on a Road. This one you had to go backwards into the other example 4 there. And then what was weird with that is that it was asking you to use the distance from. It was really worded badly. I think I might have ran out of time to re-explain here. What they were asking you to do is use the 80 feet here to be able to come to a stop. They're seeing if that was what you use that for your D value. It's worded horribly. I totally forgot to remind you guys of that.
Confused about that.
So when you get back to this, and you might have set it all through, it's a lot easier than you think. If there's something like this on a test at any point, believe me, the word problems that I use, the ones that I write, are very concise and to the point. There is no ambiguity in school. Big word for Murphy today. It's pretty straightforward what I'm looking for. Okay. So here I'm just going to say this. I set this equal to 80 and I solve for x. Okay. You wind up using the I would just use quadratic formula because it's got decimals in it. When you do that, I think you get like 25-ish or something like that. Did you use quadratic?
25.5. I just did it in the calculator.
Oh, that's fine.
Between 25 and 26.
That's fine. So it's 25-ish. Okay. Now, careful on the test. I might say, oh, but it was saying miles per hour. Okay, you're fine because it was
Well,
saying.
because it's like negative 2.5 is 25 and then 2.68 is 26.
Yeah, so you'd say the safe thing would be about 25, right about 25 miles an hour. Okay. I was going to say, but I'm thinking about different rounding stuff. But yeah, it's just a matter of using that out and it goes from there. Okay. What do you got? Like I just said, this problem, it didn't tell you that you had to use the 80 from an earlier part. It was worded like horse patootie. Same thing with 90. In 90, I think this is a little bit easier. This mirrors the same idea of the Big Bertha cannon shot. What's different here is notice the model. The Big Bertha cannon shot started at 0, didn't it? This one is starting at 5.5. Why is it starting at 5.5?
It's 5.5.
She's starting here, throwing it from 5.5.
Is that?
The initial height is it starting at 5.5 feet and then going from there. I know, but they're saying that cannon's on the ground. They're shooting it up. So here, what you're looking at again is instead of the 0, instead of your curve starting at 0, it's starting at 5.5 feet, and it's still landing here at some value. Okay. So what we're looking to find is what is that horizontal distance that she threw it. Okay, that's what the x values are looking for. So when you set that up in your calculator, once again, you're looking for where x is jumping from. If you go to your tables, you're looking for where x is jumping from a positive value to a negative. That'll give you a good approximation. Or, let's put this one in. I'll show you another one you can do. Negative 0.024 something, 1 x squared plus x plus 5.5. Everybody agrees that it crosses the x-axis somewhere, right?
Yeah.
Okay. Everybody also agree that she's probably not throwing a shot put 200 feet.
Yeah.
You never know.
You never know. I mean, you know, it's Jackie Joyner Kersey, so I'm going to set this at like 50. Do we also agree that it's probably not going 100 feet in the air?
Yeah.
I mean, she might be Wonder Woman.
I think she is.
You know, Wonder Woman jumps tall buildings. We'll say 50 maybe. Notice I'm just doing some rough approximations of, you know, just using my brain about how far things can get thrown. So on your calculator, if you hit second trace again, what's option number 2 looking for?
0.
What do you think that's going to calculate?
How far it goes.
It's going to calculate where it's crossing the x-axis. It's going to give you that approximation instead of going through your table. So if I check this by solving for my 0, I select the 0, and it's going to ask me those same questions that it did yesterday, like your left and right bounds. So what I'm going to do is move my cursor over close where it's going to cross. I'll get there eventually. And I'm just going to set enter, and then I'll pick a spot on the other side of it where it crosses the axis.
Wait, so you put it right on?
No, I'm going past it. I'm going, and it says that silly guess again. So it's saying the 0 is at about 46.41 feet is where it's crossing. So what that's saying is that her horizontal distance of throwing is almost 46.5 feet with a shot put. It's depending upon where you're setting your boundary. Okay? If you move the boundaries a little bit closer to one another, it's going to be it'll narrow itself in to get a little bit better of an approximation. But also, if you go to your table, and I know that it's happening somewhere around 46. If I look at my table and just scroll through, everybody see how it's switching from positive to negative between 46 and 47?
Yeah.
So that means it's a little bit more than 46 feet she's throwing it.
But like on the test, how exactly do you want it? Because like with the table, you can just kind of guess around 45.
Right, and then what I would probably say is I usually round things to the nearest 100. So I'll say, for something like this, I'll say round it to the nearest 100, which means you'd have to use the calculate function. All right, and everybody's going to be within that realm of, depending upon where they set the boundaries with their windows and stuff, how close you're going to be, and that's fine. All right, everybody's going to be, you're going to be off between just each other depending on where you're clicking. Yes, sir.
Is there going to be a lot of work hours in the test?
I think there's 3.
How many
Okay.
questions are there?
What is this test?
And then did you
Tomorrow.
make up your mind whether we're gonna choose which like way to do the rounds or?
Yeah. Let me choose your own.
Oh.
I did not know that.
The other one, the last set. One of the things that we ran out of time yesterday, and I was hoping that you just flip back a page to read about it, was how you use this modeling for objects in motion. What's happening here is that there is a difference between throwing an object and dropping an object. What's the difference?
Alright, so when
One
you
goes
drop it, it
down.
starts at the height, one drops down, and then when you throw it, it starts
There's a velocity.
over there.
There's a horizontal movement.
Same, I mean,
It's throwing something, okay, versus dropping something. So you still have an initial velocity. It's a great question. What if I throw it down? There's still an initial velocity. Your initial velocities, you can have a couple of different things. You can have a direct horizontal velocity where it's just straight across. Gee, nothing up your sleeve. You can have an upward velocity where you're throwing it up in the air and coming down, or you can have a downward velocity, thinking of spiking a volleyball, which is one of the problems. You have a negative velocity. Okay? What, the volleyball one?
There's so many balls.
why?
So what's happening in these then, if you look at, what was the first one? 75? The diving one, here's what I want you to think of. When you're talking about this diving problem, you have some guy up here, and he's jumping up, and he's jumping into the water. When he starts his jump, he's got an initial upward velocity of 5 feet per second. Now, all of these style problems all use the same basic model. Negative 16 times squared plus the initial velocity times time plus your initial height. What that V subscript O, think of it as original velocity, initial velocity, same thing with the height. That height, when we did the Jackie Joyner Kersey shot put, the initial height was 5.5 because she was holding it 5.5 feet off the ground. Here, your initial height is 92 feet because he's standing up on a cliff, ready to jump out. Yes?
We need to remember the.
I'll give you the models.
Okay.
Models will be given, okay? Now, in this case, it's saying that your initial height was 92. Your initial velocity is 5 feet per second. But before it says upward. So is upward a positive or a negative? Positive. So what I'm doing here is I have the following model. Negative 16t squared plus 5t equals 92. Okay? So what the t value stands for is time. What you're trying to figure out is when does time equal 0? How long is he in the air? So if you're in the air for so long, then all of a sudden you're underwater. So that's where this changes. You're trying to find this to equal 0. In these cases like this, quadratic formula is really fast to use. Okay? Or you can do the calculate 0. It should work it should get the same value. I just use quadratic formula, opposite of b, plus or minus the square root, b squared minus 4 times a times c all over 2a. Now I kind of choked that together a little bit. When I set this up, I'm going to get 25 plus 4 times 16 times 92. The reason I'm saying that it's plus is because it's minus 4 times negative 16. Everybody okay with that? Yeah. All right. Thank you. So underneath my radical, I'm getting 5913. Everybody okay with that?
Yeah. What?
Now, which one of these two values am I going to throw out?
whatever makes the negative.
Notice I'm dividing by a negative. What do I want my numerator to be then? I want it to be negative as well. Because what's negative divided by negative?
Positive.
Positive. Is that- So in this case, I need to throw out the positive value here because I'm dividing by a negative. So my answer will wind up being -5 minus the square root of 5913 divided by -32. I don't know what that answer is, but that's what the answer is.
Like, you can just do that.
4.56.
Well, if it's asking how many seconds, it's -5 minus square root of 5,913 divided by 32 seconds, my friend. I don't know what that means. I know what 6 is, though. 1, 1,000, 2. I can't say -5, 1,000, but that just doesn't work. I know, I'm sure. You give me a number, right?
I'll have to remind
2.56? There you go. I know what 2.5 seconds looks like. Blink. Blink. There it was.
You what?
That was 2.5 seconds of your life you'll never get back.
Alright.
Nah, not
76 is awful. Don't worry about it.
Oh, yes, hallelujah.
Volleyball,
What was the answer though?
I don't remember. It's something really awful.
Oh, 1.5.
When you go through the last 3, though, these last 3 mirror the idea of what a modeling question might be on a test. Notice how they all give you, well, except for 77. 77, they didn't write the actual formula in. But 78, 79, and 80, see how they all give you the formulas? That's the things that I do. I give you the formula that you have to interpret out of. Whether or not you're solving like the vertical one, figuring out the horizontal distance. How high up does it go? Something like that. With the volleyball one, you're starting out with, you're spiking the ball over the net that's 10 feet above the court. Your initial velocity is -55. So you're using that -16 t squared initial velocity plus your initial height.
It's like on the test, that would be the.
That would be there, okay? You have to fill in the blanks though. When I fill in the blanks on that, what do I get for my initial velocity?
-55.
It's -55, because it's telling you it's negative, and then what's the initial height? 10. So, -16 t squared plus, minus 55 t plus 10. Set it equal to 0 and solve for t.
How did you get negative? Was that like how the-
It's going to be again part of the model. So these, whenever you have an initial velocity style problem where something's getting hit, thrown, hit, dropped, whatever, you always have the same model. And that model starts out with -16 t squared plus your initial velocity times time plus the height. I will give you, if you need this model, I'll give that to you. Okay, I'm not going to make you memorize that because it's not something you need to use all the time. It's not like that. All right. Now I know that probably just by going over those handful of problems has probably cleared up a lot of the mess.
Yes.
Good. Don't forget how to factor. Don't forget how to work with imaginary numbers, and you're going to be fine about it. Okay? It's very, very, very straightforward.
So, like, I have one question about the So, if say if it's like you ended up, the answer can be negative square root something.